First, we're going to start with strong acids and strong bases, and it's nice because we're going to ease in. They're pretty straightforward. There are 7 strong acids. They are going to need to be memorized, but there's not too many, and they're pretty, there's like a nice technique to it. So all of the halide acids, other than fluorine, are going to be strong. So hydrochloric acid, hydrobromic acid, and hydroiodic acid, as well as nitric acid, sulfuric acid, and the 2 chloric acids, so chloric acid, HClO3, and perchloric acid, HClO4. By definition, strong acids are also strong electrolytes, and we did talk about that back in the solutions chapter, because when you put them into water, they break up completely into ions. So basically, I have one of the acids, I add it into water. This is not an equilibrium process. It goes forward completely to where I get hydronium ion and the conjugate base. So that means that since I go completely into acid or into ions, then my concentration of my acid that I begin with goes all the way into hydronium, or H plus ion. This means that it's really easy to find my pH, because if I know the concentration of my acid, I know the concentration of hydrogen, and therefore I know my pH. Strong bases are basically the hydroxides, the soluble hydroxides. They are alkaline metal and heavier alkaline earth metal hydroxides, so calcium hydroxide, strontium, and barium. Even though their solubilities are low, they are still strong. They have hydroxide, and so they are going to be strong bases. Once again, they're going to completely break apart into their ions, completely dissociate. So I might have, if it was an alkaline metal, the metal plus the hydroxide completely going into hydroxide plus the metal ion. If I have an alkaline earth metal, I'll have 2 hydroxides attached, dissociating into 2 hydroxides and the metal ion. So we're going to take that. So if you know the concentration of your metal hydroxide, you know the concentration of hydroxide. Keep in mind, if it is like an alkaline earth metal, you know the concentration of that. You'll need to double it to find the concentration of hydroxide, since it's going to dissociate into 2. So let's practice. If I want to find the pH of a solution of perchloric acid that has a concentration of 0.04. So perchloric acid, concentration is equal to the hydrogen ion concentration, and that's 0.040 molar. So the pH is just equal, this is always the definition, negative log of hydrogen concentration, and since it's strong, it goes straight over. So I get negative log of 0.04 molar, and that gives me a pH of 1.40 for A. An aqueous solution of nitric acid has a pH of 2.34. So that's a strong acid. So we're wanting to find the concentration of the acid. Well, that's going to be equal to the hydrogen concentration, which we can find by taking 10 to the negative pH. So I can do 10 to the negative 2.34 gives me a concentration of 4.57 times 10 to the negative 3rd molar of nitric acid. Right. So pH of a 0.028 molar of sodium hydroxide. So sodium hydroxide only has 1 hydroxide. So if I know the concentration of sodium hydroxide is going to be equal to the concentration of hydroxide, so that is equal to 0.028 molar. So if I want to know the pH, well, first I'm going to find the POH. So I'm going to do POH equals negative log of the OH, which equals negative log of 0.028 molar. So that gives me a value of 1.55 for POH. Then 14 minus POH equals pH. So I'll do 14 minus that answer, and I get a pH equal to 12.45. For this next one, I have a calcium hydroxide solution, has a concentration, of 0.0011 molar. So that means because I have two hydroxides, my concentration of hydroxide will be double that, 0.0022 molar. So now I can find, let's do the other way. We'll do Kw equals equals OH times hydrogen ion. So we know hydroxide, so 1 times 10 to the negative 14 equals 0.0022 molar times hydrogen ion. So we'll divide that over 1 times 10 to the negative 14 divided by 0.0022. So my hydrogen ion concentration equals 4.54 times 10 to the negative 12. And I'll take the negative log of that answer to get pH. So the pH of the negative log of this answer is 11.34. So very basic, which makes sense because I just added a strong base.